Madam, please, sir, please,
Shall I?
sir, please start the session.
Yeah. Namaste, everybody. Welcome back to our webinar session of mathematics. Usha Sree Madam is here. We are coming after a small break. And Usha Sree Madam will make the chapter complex numbers very simple to you and present it before you. So, Madam, Usha Sree Madam, over to you. Please
Thank you,
take
sir.
over.
Thank you, sir.
Yeah.
Good afternoon, everyone. I'm Usha Sree, again back with the next session of complex numbers. The topics which we are going to take up today, they are involving some 4-mark questions for our IPE exams. Before we start with the session, children, let us try to recall what we have taken up in the previous session. We have seen representing a complex number in A plus IB form, right? When we had I term in the denominator, we tried to multiply and divide with the conjugate, and we have reduced the given complex number into A plus IB form. Then, what is conjugate of a complex number? This we have seen when Z is equal to X plus IY is a complex number given to you, then the conjugate will be represented with Z bar and it is X minus IY. Then we have seen modulus amplitude form of a complex number. That means any complex number which is of the form X plus IY can be represented in the form of R into cos theta plus I sin theta. Okay, R is nothing but modulus of the complex number, which is nothing but root of X square plus Y square, and amplitude is nothing but theta. Theta will be given by tan inverse of Y by X, right? And we have seen the problems how to express a given complex number in modulus amplitude form in the previous sessions. Okay, now what we are discussing today. The topics for today are locus of a given complex number, locus of the given complex numbers, how to find with the given conditions, we will try to find the locus. And then geometrical representation of a complex number. When a complex number is given to you or an expression in complex number is given to you, then how what geometrical representation you are able to deduce out of that. We will see into these concepts. We'll start with a question, children. If Z2 by Z1, Z1 not equal to 0 is an imaginary number, then find the value of mod of 2Z1 plus Z2 divided by 2Z1 minus Z2. Now, before we get into the solution of the problem, we will try to see in detail what exactly is the question telling you. Z2 by Z1. Z2 is a complex number. Z1 is also a complex number. The condition on the denominator, what we are taking is Z1 is not equal to 0. When your denominator is 0, then you cannot define this number, isn't it? So he is specifically mentioning Z1 is not equal to 0. Then what type of number you are getting when you take this expression Z2 by Z1? Z2 by Z1 is an imaginary number. That means real part of the complex number is missing here, isn't it? So it's purely imaginary number. Right. So when you have imaginary number, it means that it will be of the form 0 plus some IY. The real part is missing. Now we'll start with the solution, children. Now you are given that Z2 by Z1 is an imaginary number. So as we said, the real part is missing. We will say let Z2 by Z1 is equal to IY. Since it is an imaginary number, the real part is taken as 0. Actually, a complex number will be of the form X plus IY, but X is 0. X is the real part, isn't it? So that X is 0, that's the reason why we are taking Z2 by Z1 as IY. Now, we will just take our question, modulus of 2Z1 plus Z2 by 2Z1 minus Z2. But directly, see, we know the condition as Z2 by Z1 is equal to IY. By some means, we will try to get Z2 by Z1 into the problem. How can I get that? If I divide the numerator with Z1 and also the denominator with Z1, then there is a chance of getting Z2 by Z1. Let us see that. Now, when I divide my numerator with Z1, 2Z1 by Z1 is 2, isn't it? And then you have plus Z2 by Z1. Similarly, in the denominator, 2Z1 by Z1 is 2, because Z1 and Z1, they are getting cancelled, minus 2Z1 by Z2. Now, we are in a position to substitute Z2 by Z1 is equal to IY. Since we know only this value, we are trying to reduce the problem into a form where we can use this condition. Okay, children, hope you got that. Then we will just take 2 plus Z2 by Z1 is IY, then 2 minus, this is IY again. So mod of 2 plus IY by 2 minus IY. Now we have seen one important condition when we have taken modulus. Mod of Z1 by Z2, when you are calculating, it can be always taken as mod Z1 by mod Z2, isn't it? So making use of that, we will try to take modulus of numerator and modulus of denominator to calculate this. What is modulus of any complex number? Square of the real part plus square of the imaginary part under the root, isn't it? So here the real part is 2. So 2 square is 4 plus here the imaginary part is y. So y square under root. So root of 4 plus y square. Here again, real part is 2. So 2 square is 4. Imaginary part is minus y. So minus y whole square is plus y square. So root of 4 plus y square and root of 4 plus y square in the denominator also, they get cancelled and you will be left with the answer as 1. Right? This is an interesting problem. Only thing is, you should get an idea, like you should take Z2 by Z1 is equal to IY and how to reduce this into Z2 by Z1 so that we can make use of this condition. We'll see one more problem. If root 3 plus I whole power 100 is equal to 2 power 99 into A plus IB, then show that A square plus B square is equal to 4. Okay. Now we are given with the condition that root 3 plus I whole power 100 is equal to 2 power 99 into A plus IB. Now, see, this is the condition given to us. We can apply any conditions on this given part. That is, you can take modulus on both sides, or you can take root 3 plus I in modulus amplitude form. Then you can compare it, but it will be too lengthy. If the problem is given in your IPE exam, sometimes it may be given for 2 marks also. Now, for that reason, we will try to go for a shorter version of the problem so that you can quickly get your answer. So to do this problem, we will take modulus on both sides. When I apply modulus on both sides, that means I am applying a condition on both sides of the given statement. So the meaning of the problem will not be changed. So when I calculate the modulus on either sides, I will get it as, now look at this, children. Your real part is root 3 and imaginary part is 1 when I take root 3 plus I. So root 3 whole square plus 1 square under root is modulus of root 3 plus I, and you have power as 100. So we will take it as power 100. And on the right hand side, you have 2 power 99. We will keep it as it is. For 2 power 99, modulus is 2 power 99 only. And root of A plus IB is nothing but, modulus of A plus IB is nothing but root of A square plus B square. Now, under the root, root 3 whole square will be 3 right? And this is 1. 3 plus 1, 4. 4 under root will be 2. So you will be taking 2 power 100 on your left hand side. 2 power 100 is equal to 2 power 99 into root of a square plus b square. Now 2 power 100 by 2 power 99 will give you only 2, isn't it? So we will have it as root of a square plus b square is equal to 2. But what is that we need to prove? We need to prove a square plus b square is equal to 4. So when you take squaring on both sides, children, that root gets cancelled and you will be left with a square plus b square is equal to 2 square is 4. So what is that we have taken? We have taken modulus on both sides of the given condition. This is the important point which you need to observe in this problem. Right? We will go with the next problem. If 1 minus I into 2 minus I into 3 minus I and so on, 1 minus Ni is equal to x minus Iy, then prove that 2 into 5 into 10 so on till 1 plus n square is equal to x square plus y square. This is the next problem. Now you are given with the condition, children, 1 minus I into 2 minus I into 3 minus I and so on till 1 minus Ni is equal to x minus Iy. Okay, here if you observe carefully in the problem, see, before you apply some condition, you need to analyze the problem, isn't it? So if you observe your right hand side, what you need to prove, it is showing you x square plus y square, isn't it? So observe this. When do you get x square plus y square? When you take square of modulus of the complex number which you have on your right hand side. Then with that small idea, try to observe what you have on your left hand side. You have 1 minus I. Here you are getting it as 2. 1 minus I. That means 1 square plus 1 square gives you 2 under root. When you take modulus of this, you are getting root 2, whole square will be 2. Likewise, try to observe each bracket on your left hand side. It is nothing but the modulus of each complex number, what is given on your left hand side. So before you proceed with the problem, whichever may be the problem, you need to just observe what you need to prove, and accordingly, you need to go for the solution. Now, for this problem, we will apply modulus on both sides. Then when you take modulus of each term on your left-hand side, first we will try to calculate. What do you have? See the first one, 1 minus I. Modulus of 1 minus I is nothing but root of 1 square plus, here this is 1 square, that is minus 1 square, which is nothing but 1 square. So this is root 2. Then next 2 square plus 1 square under root. Then this is 3 square plus 1 square. And for this one, this is root of 1 square plus n square. That means modulus of each individual complex number is taken on your left hand side. And likewise, on your right hand side, modulus of x minus Iy is root of x square plus y square. Now on simplification, you will have it as 2, this is 5, this is 10, this is 1 plus n square, this is x square plus y square under the root. Now when you take squaring on both sides, children, then you will have only 2 into 5 into 10 and so on till 1 plus n square is equal to x square plus y square. So the two problems what we have discussed, this one and the previous one, they are involving taking modulus on both sides for the given condition. And this problem is again for 2 marks. Right? The next question. Show that the equation of any circle in the plane is of the form z z bar plus b z bar plus b bar z plus c is equal to 0. Now we have to show the equation of any circle in the plane will be of this form. Actually, by this time you are very familiar with the general equation of a circle, children. We will try to take general equation of a circle in our Cartesian form. Then we will try to represent that in the form of complex numbers, and we will try to get z and z bar into the problem. Okay. Now we'll start saying, let the equation of the circle be, what is the general form of the equation? By this time, maybe you are ready with the equation, that is x square plus y square plus 2gx plus 2fy plus c equal to 0, right? We will call this as equation 1. Now let us say z is a complex number which is involved in the problem, as you can see in the question itself, right? So let z is equal to x plus iy. When z is equal to x plus iy, automatically the z bar, that is the conjugate of this complex number, will be x minus iy, right? So we will try to consider what is z plus z bar. Z plus z bar, that means we are adding x plus iy plus x minus iy. When we do so, iy and minus iy, they get cancelled. Then you will be left with 2x. So z plus z bar is nothing but 2x. Now we'll try to consider what is z minus z bar, children. Now z minus z bar is x plus iy minus of this, isn't it? So you will get minus x plus iy. So here x terms are getting cancelled. That is x and minus x, they get cancelled, and you will be left with 2iy, right? Then we will consider z minus z bar by 2i. Z minus z bar. What is z minus z bar? We have seen 2iy, isn't it? So z minus z bar, we will substitute 2iy by 2i. It gives you y. But can you have 2i in the denominator? You cannot. So what is that you should do? You should multiply with its conjugate and also divide. So z minus z bar by 2i into I by I. Now observe this, children. This is equal to y, of course. Now I into z minus z bar, we will keep it as it is. Then 2i into I becomes 2i square. But what is I square? I square is minus 1. So that minus, when you shift to the numerator, you will have it as minus I into z minus z bar is equal to 2y. We are just sending this 2 here. So it becomes 2y. Okay. I square is minus 1. That minus is taken in the numerator. So we are getting a condition here. Minus I into z minus z bar is equal to 2y. And the previous condition was z plus z bar is equal to 2x. Okay. Now, since you have z as x plus iy, modulus square, that means mod z whole square. What is mod z? Root of x square plus y square. And for that root, you are taking square. So you can clearly observe that square root is getting cancelled. So mod z whole square is equal to x square plus y square, which can also be taken as z into z bar. Okay. Now, we will substitute all these conditions in equation number 1. In what is your equation 1? We have taken the general circle equation, that is x square plus y square plus 2gx plus 2fy plus c equal to 0. We got x value, we got y, and we can also substitute z and z bar in the given problem, right? When we substituting in 1, we have x square plus y square plus 2gx plus 2fy plus c equal to 0, right? This implies z bar plus g into z plus z bar plus f into minus I into z minus z bar plus c equal to 0. Now, how did we get this? Let us look into this. What is our value of x and what is the value of y? If you can analyze that, that is giving you zz bar plus g into 2x, isn't it? See, g into x square plus y square is zz bar. 2g into x, that means g we are separating, 2x is nothing but z plus z bar, and f we are bringing it out, 2y is nothing but minus I into z minus z bar plus c is equal to 0. Now, we will further expand this, children. When you expand this, z minus z bar remains as it is. See, you have g into z, you have minus if into z. So we are separating z terms. So when I take z as common, from here you are getting g, from this you are getting minus if. Okay, and next is z bar, that is conjugate of z. So z bar, when I take common, from this term you are getting g, and from this term minus I into plus z bar is plus I into f, isn't it? So plus if, z bar is out, plus c is equal to 0. So why did we do all these calculations? Here also we can do that, but only thing is when you calculate it separately, you can avoid some confusion and it will be comfortable for you while solving the problem. Now, let us take g plus if is equal to b and g minus if is equal to b bar. Why so? Now in your problem, if you can observe your question, b bar are used. You don't have g minus if and g plus if. Now g minus if and g plus if are both complex numbers. So one of them, if you take it as b, the other one should be the conjugate of that complex number. So it is becoming b bar. So when you substitute the conditions what we have taken, we will get it as zz bar plus, what is this? This is b bar, isn't it? So b bar into z plus, this is g plus if is b. So b into z bar plus c is equal to 0. Now this problem will be generally for 4 marks, children. You don't have any 7-mark questions from this chapter. So the questions will be confined up to 4 marks only. We will see some problems where we will have to describe geometrically what exactly the locus is representing. So for this, the question is, if z is equal to x plus iy and if the point P in the argand plane represents z, then describe geometrically the locus of P satisfying the equations. Number 1, mod of 2z minus 3 is equal to 7. The expression which is given to you is mod of 2z minus 3 is equal to 7. You are already given that z is equal to x plus iy. First, we will try to simplify the given condition. Then we will try to analyze geometrically what exactly the locus is showing you. So you are given that mod of 2z minus 3 is equal to 7. Z is equal to x plus iy. So instead of z, we will substitute that. So mod of 2 into x plus iy minus 3 is equal to 7. Then we will try to separate the real part and the imaginary part. You have it as 2x minus 3 plus I into 2y. See, this is 2x plus 2iy. So that I into 2y is taken as the imaginary part equal to 7. Now we know the real part and imaginary part. We can apply the formula for the modulus. Right. Modulus is real part square plus imaginary part square under root. So you have it as root of 2x minus 3 whole square plus 2y whole square is equal to 7. We'll expand this, children. The first bracket is telling you a minus b whole square, isn't it? So we will take it as 2x whole square, which is 4x square, minus 2 into 2x into 3, plus 3 square is 9, plus 2y whole square is 4y square equal to 7. Now, on further simplification, we will have it as root of 4x square plus 4y square minus 2 into 2x into 3 is nothing but 12x plus 9 is equal to 7. We will take squaring on both sides, children. Then we'll have it as 4x square plus 4y square minus 12x plus 9 equal to 7 square is 49. Get all the terms to one side. Then you will have it as 4x square plus 4y square minus 12x plus 9 minus 49, which gives you minus 40 is equal to 0. Now you can take 4 common throughout the equation. Then you will have it as x square plus y square minus 3x. 4 is out, isn't it? Then minus 10 is equal to 0. Now, if you observe this equation carefully, it is a second degree equation where the coefficient of x square and coefficient of y square are same, and you have some 2gx and 2fy terms also and one constant. So this equation is representing the locus of the given complex number is x square plus y square minus 3x minus 10 equal to 0. And this equation is of the form x square plus y square plus 2gx plus 2fy plus c equal to 0, which represents a circle. Okay, when you compare the two equations, the general equation of a circle and the equation what we got, you will get g and f values and also c. 2g is minus 3. 2f, we don't have any y term, isn't it? So 2f is 0 and c is minus 10. We know the center of the circle will be represented with minus g comma minus f, isn't it? So the center of the circle minus g minus f will be taken as 3 by 2 comma 0. Your 2g value is minus 3, children. So g will be minus 3 by 2, but you should take minus g. So it is minus of minus 3 by 2, which is 3 by 2 comma 0. And then radius will be calculated with the formula g square plus f square minus c. So you will have it as root of 3 by 2 whole square plus 0 plus 10. C is minus 10, so minus of minus, which is plus 10. Then you will get, this is 9 by 4 plus 10, which is nothing but 9. When you take LCM, 9 plus 40 by 4 under the root. So 49 by 4 under root is nothing but 7 by 2. So radius is nothing but 7 by 2 units. So the given expression, which is in complex number, which is in the form of a complex number, is representing a circle, x square plus y square minus 3x minus 10 equal to 0, right? With center 3 by 2 comma 0 and radius 7 by 2 units. When the question is given, like you need to describe geometrically, you need to explain all this. Now, if it is not mentioned, then it should be a 2-mark question, children. It will be only a 2-mark question because you will simply take z is equal to x plus iy and then complete your problem by writing the locus. Now, the next question. Mod of z plus I whole square minus mod z minus I whole square equal to 2. This is the question given to us. Now, here again, in the problem itself, he said you should take z is equal to x plus iy. So we will, wherever we have z, we will substitute x plus iy. So x plus iy plus I in the modulus whole square and x plus iy minus I. You're taking inside the modulus and whole square equal to 2. We will try to rearrange this like real part plus some imaginary part. When you do so, you will have x plus. From these two, I can take I common and I can write it as y plus 1. Then remaining minus is as it is. Here again, you will write it as x plus. From iy and minus I, you are taking I common and you are writing it as y minus 1, right, inside the root, and whole square equal to 2. Now, first we will calculate what is modulus and then take square of it. The modulus of this is root of x square plus y plus 1 whole square, isn't it? But you have whole square, so that root is getting cancelled. So you are left with x square plus y plus 1 whole square. Then you have minus. Here again, modulus of this expression is nothing but root of x square plus y minus 1 whole square. Since you have whole square, the root is getting cancelled and you will be left with x square plus y minus 1 whole square is equal to 2. We will expand this. Now, x square plus y plus 1 whole square is y square plus 2y plus 1. Then you have minus x square. You have y minus 1 whole square plus minus sign outside. So you have minus y square plus 2y minus 1 is equal to 2. Okay. Now, x square and minus x square, they get cancelled. Y square and minus y square, they get cancelled. 1 and minus 1 get cancelled. Right? You are left with 2y plus 2y, isn't it? Which is nothing but 4y. So this implies 4y equal to 2, or we can say 2y is equal to 1. Now, what is that you are getting as locus? The locus is nothing but 2y equal to 1. This 2y equal to 1, or we can write y is equal to half. Y is equal to k always represents a line which is parallel to x-axis. This concept we have studied in our 9th class, or little more than that also, right? The same thing we are applying here. So the equation represents a line parallel to x-axis. Okay. We'll see one more problem. Mod of z plus 4i plus mod z minus 4i is equal to 10. We'll take the given problem and we will assume that z is equal to x plus iy as given in the question. Then we will, instead of z, we will substitute x plus iy. We will have it as a mod of x plus iy plus 4i plus mod of x plus iy minus 4i is equal to 10. Right? Then we will try to rearrange the real part and the imaginary part. So you will have it as mod of x plus I into y plus 4 plus mod of x plus I into y minus 4 is equal to 10. We'll find out modulus for both the terms on our left hand side. Then we will have it as root of x square plus y plus 4 whole square plus root of x square plus y minus 4 whole square is equal to 10. Right? We will try to take one of the terms on our left hand side to the other side. Why I am doing it? I am trying to get rid of this root on either sides. If you have one single root term on one side, then squaring on both sides will cancel the root. But here we have two terms, children. If I take squaring on both sides, then it looks like a plus b whole square, and again you will get a root term. So we will try to make our problem easy by sending one of the terms on our left hand side to the other. So you will have it as root of x square plus y plus 1 whole square, y plus 4 whole square is equal to 10 minus root of x square plus y minus 4 whole square. Now we will take squaring on both sides. When I do so, I will get this root get cancelled. Then we will have it as x square plus y plus 4 whole square is equal to, this becomes a minus b whole square. So 10 square minus 2 into 10 into root of x square plus y minus 4 whole square plus this is b square term, isn't it? So b square, when I take root, gets cancelled. Then you will be left with x square plus y minus 4 whole square. Right? Now further we will expand it. When you expand, on your left hand side, you will be getting x square plus y square plus 8y plus 16 is equal to 10 square, you are getting it as 100 minus 2 into 10, which is 20, root of x square plus y minus 4 whole square plus the last term. When expanded, you will get x square plus y square minus 8y plus 16. Okay, children? Then we will try to cancel the terms possible on either sides here itself. So x square can be cancelled on both sides. Y square can be cancelled on both sides. 16 can be cancelled on both sides. 8y you cannot. You need to observe this. Here it is plus sign and here it is minus sign. There is equality in between. So you cannot cancel this y term. Okay. So this minus 8y I will send to the left hand side. So it becomes plus 8y. So you are getting 16y and also the 100 to the other side. So you will have it as 16y minus 100 is equal to minus 20 into root of x square plus y minus 4 whole square. Now, to make our problem or the calculations little simple, first I will take 4 common on both sides and I'll try to reduce the problem. When I take 4 common, children, you will be getting 4 into 4y, which is 16y, minus from 100, 4 is out, so you will be getting it as 25. From 20, 4 is out, so you are getting it as 5. So 4 into minus 5 into root of x square plus y minus 4 whole square. Now I will cancel 4 on both sides. Then I will take squaring on both sides now. When I take squaring on both sides, you will have it as 4y minus 25 whole square gives you 16y square minus 2 into 4y into 25, which is minus 200y plus 25 square is 625. This is equal to minus 5 whole square is 25. Here the root is getting cancelled with the square. So you will have it as x square. Expand this, children. You will get it as y square minus 8y plus 16. Okay. Now we will try to get all the terms with the expanded form. Then you will have it as 25x square. I'm multiplying with 25. So 25y square minus 200y when you multiply 25 with 8y, and then 25 into 16 is 400 is equal to 16y square minus 200 plus 625. Now if some terms are getting cancelled, we will cancel. So here clearly minus 200y gets cancelled on both sides. Try to get all the terms to one side now. 25x square minus, you don't have any x square terms. So 25x square you will get as it is. 25y square minus 16y square is 9y square, and 400 minus 625 is nothing but minus 225y. So this 200 I'm getting this side, so that I'll have a form 25x square plus 9y square is equal to 225. Now I will take 25x square plus 9y square equal to 225 and I will divide with 225 on both sides. When I do so, 25x square by 225 gives you x square by 9, and 9y square by 225 gives you y square by 25, which is equal to 1. Now, the equation which you are seeing as the locus is x square by 9 plus y square by 25 is equal to 1. This is representing an ellipse. See, the topic ellipse is not dealt in your 2B paper, children. You can have a clear idea about this ellipse when you come across the topic, and in a month or so, you can see that topic also. But meanwhile, we will try to see only the overview of the geometrical representation of the given the locus what we got. The equation represents an ellipse. Here the center of the ellipse is taken as 0, 0, right? And the a square value. See, any ellipse equation will be of the form x square by a square plus y square by b square equal to 1, isn't it? So you will have a square as 9 and b square as 25. Then we have a formula in ellipse, that is a square is equal to b square into 1 minus e square, children. This e, the value e is called as eccentricity. Okay, then when we substitute a square and b square in the problem, you will have it as 9 is equal to 25 into 1 minus e square, which is 1 minus e square is nothing but 9 by 25. Or I can write e square is equal to 1 minus 9 by 25, which is nothing but 16 by 25. So this implies e is equal to 4 by 5. So the locus what we got is representing an ellipse with center 0, 0 and an eccentricity of 4 by 5. So another point which I want to mention here is, for an ellipse, the eccentricity value will be always less than 1. Okay. And when we discuss the topic locus, it will be more clear to you regarding the properties of an ellipse, how we got the center as 0, 0, what are these a square and b square. I will take up the next problem. Mod z square is equal to 4 into r, e stands for real part, children. 4 into real part of z plus 2. Okay. So you are given with the expression like this. We will say let z is equal to x plus iy. First, we will substitute x plus iy in the place of z. Then you will have it as mod of x plus iy whole square is equal to 4 into real part of x plus iy plus 2. First, we will try to rearrange these terms with the real part plus some imaginary terms. So we will have it as mod of x plus iy is root of x square plus y square, and you have whole square here, right? Plus 4 into real part of, first I will rearrange this. You will have x plus 2 plus iy. My real part is x plus 2. Okay. So what is that I should take from the bracket? Only the real part. So I should take only x plus 2. Now, square root and the square, they get cancelled. So you will have x square plus y square equal to 4 into real part of all this is x plus 2. Okay. Now we will expand this, children. X square plus y square, 4x plus 8, when you get this side, it becomes minus 4x minus 8 equal to 0. This is again like the previous one of the questions what we have seen. This is the locus of the problem and it is representing a circle equation. The circle equation with center 2, 0 and radius 2 root 3 units. How do we calculate the center? Center is minus g, minus f, children. Here the g value is minus 2 and f value is 0. So minus g minus f, it becomes 2, 0. And radius, the formula for radius is root of g square plus f square minus c. So when you calculate that, it's coming to 2 root 3 units. So when a problem is asked to describe the geometrical analysis, you need to write, children. So it is not suffice to just mention the locus. What this locus is representing also need to be mentioned in the problem. Now the next question. If Z1, Z2 are two non-zero complex numbers they are satisfying a condition. The condition is mod of Z1 plus Z2 is equal to mod Z1 plus mod Z2. Then we have to show that argument of Z1 minus argument of Z2 is equal to 0. Okay. Now you are given with two complex numbers. Those two complex numbers are satisfying this condition. Now when the complex numbers are satisfying this condition, you need to prove this. So we'll start doing the problem, children. Now first we will take the condition given to us. Mod of Z1 plus Z2 is equal to mod Z1 plus mod Z2. Then let us consider Z1 is equal to X1 plus IY1 and Z2 is equal to X2 plus IY2. Okay. Then first we will calculate what is Z1 plus Z2. Z1 plus Z2 is X1 plus IY1 plus X2 plus IY2. We will try to rearrange this with the real part and imaginary part separated. So Z1 plus Z2 is equal to X1 plus X2 plus I into Y1 plus Y2. We will take modulus of this because when you see your left hand side of the condition, you have modulus, isn't it? So we will calculate modulus of Z1 plus Z2, which is nothing but root of X1 plus X2 whole square plus Y1 plus Y2 whole square. Likewise, we will try to calculate what is mod of Z1. Mod Z1, you know Z1, right? Directly we will write the modulus, that is root of X1 square plus Y1 square. And we will try to calculate mod of Z2 also. Mod Z2 is what? Root of X2 whole square, X2 square and plus Y2 square. What did I do here? I have calculated each term separately so that I can comfortably substitute in the given condition. Now, this implies mod Z1 plus mod Z2 is nothing but root of X1 square plus Y1 square plus root of X2 square plus Y2 square. Now, the condition given to us is mod of Z1 plus Z2 is equal to mod Z1 plus mod Z2. We will just substitute what we got for both the sides, isn't it? This is root of X1 plus X2 whole square plus Y1 plus Y2 whole square is equal to root of X1 square plus Y1 square plus root of X2 square plus Y2 square. We will take squaring on both sides, children. When we do so, we will get, look at this root gets cancelled. So you will be left with X1 plus X2 whole square plus Y1 plus Y2 whole square. Now, on your right hand side, when you take squaring on both sides, you will have a square. When I take this root gets cancelled, you will get X1 square plus Y1 square. And here the root gets cancelled when you're squaring this term. You will get it as X2 square plus Y2 square. Then 2AB term we have. So plus 2 into root of X1 square plus Y1 square into X2 square plus Y2 square. Okay. Now, we will try to expand the terms on left hand side first. You will have it as X1 square plus X2 square plus 2X1 X2 plus, when you expand this, Y1 square plus Y2 square plus 2Y1 Y2 is equal to, now these terms are not changing, we are writing it as it is, X1 square plus Y1 square plus X2 square plus Y2 square plus 2 into root of X1 square plus Y1 square into X2 square plus Y2 square. Now, if you observe carefully, some terms on your left and right hand sides get cancelled. X1 square on both sides get cancelled. X2 square on both sides get cancelled. Y1 square gets cancelled. And Y2 square also gets cancelled on both sides. Okay. Then you are left with 2 into X1 X2 plus Y1 Y2 is equal to 2 into root of X1 square plus Y1 square into X2 square plus Y2 square. Okay. Now I can cancel 2 on both sides. and I will again take squaring on both sides to cancel the root which is on our right hand side. Then you will have it as x1 x2 whole square is x1 square x2 square plus y1 y2 whole square is y1 square y2 square plus 2 into x1 x2 into y1 y2. Okay, this is equal to, anyhow root is getting cancelled, so we will expand this, x1 square into x2 square plus x1 square into y2 square plus y1 square into this gives you y1 square x2 square, y1 square into this term, so y1 square into y2 square. Okay, now just observe whether some terms are getting cancelled. Hope you observe that. We can cancel x1 square x2 square on both sides, children. Likewise, we can cancel y1 square and y2 square on both sides. Then you are left with some terms on your left and right hand sides. I will try to get all the terms to one side. Then I will get x1 square y2 square plus y1 square x2 square minus 2x1 x2 y1 y2 equal to 0. Now, if you observe carefully, we can write this as x1 y2 minus x2 y1 whole square equal to 0. Just expand this and see, again you will get this statement. So, this statement can be taken as x1 y2 minus x2 y1 whole square equal to 0. Then if I take out that, if I take square root on both sides, in fact, I will get it as x1 y2 minus x2 y1 equal to 0. Then I will take this x2 y1 to the other side. Then I will get it as x1 y2 is equal to x2 y1. Okay. I will try to rearrange the terms like this. y2 by x2. Look at this. y2, and from the right hand side, I am sending x2 to the left hand side. And from left hand side, x1 I am sending to the right hand side. So we will get it as y2 by x2 is equal to y1 by x1. Right? Now, I will take tan inverse on both sides. When we do that, we will get it as tan inverse y2 by x2 is equal to tan inverse y1 by x1. What is tan inverse of y by x? It is nothing but theta, isn't it? That is nothing but your argument. So here, since you have y2 by x2, y2 and x2 represent the complex number z2, isn't it? So we will make it as theta 2, and this is theta 1. So tan inverse of y2 by x2 is equal to tan inverse of y1 by x1 can be very well taken it as argument of z2 is equal to argument of z1, right? This is nothing but the formula for argument. This we have seen in the previous sessions, okay? So get all the terms to one side. Argument of z1 minus argument of z2 is equal to 0. This is what you are getting. And the question, when you are given with mod of z1 plus z2 is equal to mod z1 plus mod z2, then you will get argument of z1 minus argument of z2 is equal to 0. Okay. Now, based on the questions what we have discussed today, you have some practice questions, children. They are on the similar grounds what we have seen today, right? You have seen how to find out the locus for a given problem. Just substituting z is equal to x plus iy wherever you have z. Okay. And then if you have modulus, you will take modulus and calculate the locus, required locus for the given complex number. You can take the screenshot of the practice questions. Thank you.
Okay. Yeah. Good afternoon, everybody. Madam Sree Madam, she gave a good presentation about the locus of the complex number and also the geometrical representation of the complex numbers. And I'm sure because I have been seeing that the students are solving the problems and they were putting it in the chat. So perhaps they don't have doubts and they've been practicing. So it went off well, madam. So thank you for the good class. So I am sure the students will go home and practice some more problems and make themselves perfect. So now complex numbers will become simple numbers for them. I'm sure.
Thank you, sir.
Thank you,
Thank you.
ma'am. Thank you. Manjari. Hello.
Just a minute.
Hmm. Okay, I think until then you just keep a quick as to what we'll be doing.
Right. Now, just observe the practice questions, children. Your first problem will be a simple one. That is z is equal to x plus iy. Just substitute z is equal to x plus iy. Just apply the formula for modulus, equate it to 1, right? Then squaring on both sides will give you the solution. Now, the next question is argument of mod, Z1 bar and argument of Z2 are pi by 5 and pi by 3. We have discussed the formulae related with the argument of Z1 and argument of Z2. Just apply that. That gives you, see, when you have Z1 as a complex number, right? If theta is the argument of the complex number, then argument of its conjugate will be minus theta. So here argument of Z1 bar is pi by 5. So you can calculate what is argument of Z1 with a hint what I have given, and argument of Z2 is pi by 3, isn't it? So you can just substitute in the given condition and get the result. Now, the third question is z plus 1 by z plus I. The real part of this is equal to 1. So just substitute the value of z as we were discussing as x plus iy, right? Try to write it in some real part plus some imaginary part. Then observe whether the problem is in a plus ib form. First, try to get the problem into a plus ib form. Then take the real part of that a plus ib form, equate it to 1. Hello. Okay. Then you can get the locus of the given problem. Then similarly, fourth and fifth problems. We have done enough problems, I think, today in our session. We have just substituted z is equal to x plus iy. Then write real part plus some imaginary part. Then apply the modulus. Then simplify. That gives you the required condition. And likewise, the last problem also. But be careful, children, whenever you are solving any problem, just observe whenever, before applying any condition, just see whether you have any I term in the denominator. If you have any I term in the denominator, first you need to multiply and divide that with its conjugate and get and reduce the problem into a plus ib form before you proceed further. Okay, hope now you can start doing your practice questions also with the hints what I have provided, right? And try to learn the formulas and the conditions for the argument and also the modulus amplitude form. Some conditions we have discussed. So those conditions you need to memorize, or with practice also you can remember that. that makes your problems easy.
Yeah, so that's a nice revision, ma'am. And so you mean to say that to the extent possible, the students should always, not extent possible, rather they have to ensure that
Yes.
the complex number should be brought in the form of
Okay, I
x
think
plus iy.
madam is busy.
Yes, that is the prerequisite condition, sir. Before we proceed to the procedure of the problem, what is asked, whether it is locus or whatever it is,
Yeah.
the question should be always reduced
Yeah.
into
And
A
we,
plus IB form.
AB form. And then only we have to proceed further.
Yes,
The
we have
process
to
should
proceed.
continue after it has been brought to the A plus IB form.
Yes.
And from the second point is important point that the students should keep in mind is that the denominator should not have an I term. It should
Yes.
have only a real number term, and
Yes.
the numerator can have it, so that it will be
Yes.
easy for us to work out. Am I
Yes.
right, madam?
Yes, sir.
Yeah. So we
And
need to keep
even
it.
for simple problems like additive inverse, multiplicative inverse also, you
Yeah.
need to reduce the problem into A plus IB form, children. Again and again, I'm specifying A plus IB form is the basic statement or the basic condition what you should derive it when you start with any complex number. If the problem given is already in the A plus IB form, then you can say you are ready to solve the question. Otherwise, you will have to first bring it into A plus IB form.